Amazing morning. So for today, we're going to have, for this week, week 3, we're going to have lesson 4 and lesson 5, and that is all about geometric sequence. So at the end of the lesson, so the learner is expected to determine the common ratio of the given geometric sequence, give the next n term of the given geometric sequence, and apply the concept of geometric sequence in real life situation. Okay, let's have number 1. So we have 2 and 8. So 8 divided by 2 is equal to 4. So that's the ratio. Now let's have number 2. We have negative 3 and 9. 9 divided by negative 3. The answer that we have is negative 3. And then let's have number 3. We have 1 and 1 half. So 1 half divided by 1. And that is 1 half. No? Then let's have number 4, which is negative 5 and negative 10. So negative 10 divided by negative 5, we're going to have a positive 2. And then let's have number 5, which is 12 and 4. So 4 divided by 12, so we have 1/3. Next, let's have number 6. We have negative 49 and 7. 7 divided by negative 49. So the answer that we have in here is negative 1/7. No? Then we have 1/4 and 1/2. So we're just going to have the reverse of the other. So 1/2 times 4/1, okay, which is equal to 2. Then let's have number 8, which we have a squared and a cubed. No? A cubed divided by a squared. So we're going to have in here, the laws of exponent, wherein if we are dividing, terms, so we're going to subtract, the exponent. So 3 minus 2 will be 1. So that's why 3 cubed divided by a cubed divided by a squared. The answer that we have is A. And then, we have number 9, which is k minus 1 and k. So that will be k divided by k minus 1, or k over k minus 1. Then let's have number 10, which is 3m and 3mr. So we're going to diminish, 3 divided by 3, we have 1. M divided by m is 1. So the only thing that we have is r. While in geometric sequence, we have a sequence where each term after the first term is obtained by multiplying the preceding term by a non-zero constant, which is the common ratio. And the formula that we're going to use is the n term is equal to the first term times the common ratio raised to the number of terms minus 1. Let's have the illustrative example. So the number pattern that we have in here is 1, 2, 4, 8, 16, which is a geometric sequence. 2 is multiplied to any term to get the next term. Therefore, we can say that 2 is the common ratio. And the common ratio may be an integer or fraction, negative or positive. It can be found by dividing any term by the term that precedes it. And the number line below illustrates the sequence. So we have 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So if we're going to have the next term, 16 times 2, which is 32. So using the picture above, we illustrated and proved that the common ratio is equal to 2. So since the common ratio is equal to 2, the first term, that is 1. 1 times 2, which is the second term. The third term is 4. The fourth term is 8. The fifth term is 16. The sixth term is 32. And the seventh term is 64. So the next two terms are 32 and 64. Okay? So if we're going to get the 8th term, we're just going to multiply it by 2. Diba? And then to have the 9th term, 8th term times 2. Okay? Okay, let's have activity 2, fold me up. So let's start it with a big square. So I have in here a big square. Okay. Now, supposedly, let's suppose that this square, no, with 8 by 8 inches, no, from a piece of paper, no, assume that the area of the square is 64 square units. Now let's assume that this square, no, the area of the square is a 64 units. So let us fold the four corners of the to the center of the square and find the area of the resulting square. Okay, so let's have it. Okay, let's fold it. Okay, so we're done folding. Now let's take a look on the dimension of this square. Okay, so from 8 by 8, we're going to have it here. No. And fold it into half. No. So we can assume that the area will be divided into 2 as well. No. So if the first area is 64 of the square, okay, let's have it 64, no, divided by 2, we're going to have it as 32 divided by 2, we're going to have it 16 divided by 2, we're going to have 8. No? So what is the area of the square formed after the first fold? So we have 32. No? Second fold we have 16, and the third fold we have 8. No? Now, is there a pattern in the areas obtained after 4 folds? No. Now, what do you think will be the fourth fold? It will be 4. No. So the pattern that we have in here, so we had divided by 2. No, the area is divided by 2. So you have generated a sequence of area. So what are the first 3 terms of the sequence? So what are those? So we have 64, 32, and 16. Using the pattern in the areas, what will be the 5th term of the sequence? So having the 5th term, so we're just going to divide. Now this will be the 4th term divided by 2. No? So that will be 8 divided by 2. So the answer for the 5th term of the sequence will be 4. Let's have rule of geometric sequence. What are the 5 terms? First 5 terms of geometric sequences. First term is 5, no? And whose common ratio is 2. So a sub 1 or the first term is 5, given that the first term is 5. And then since our common ratio is 2, so we're just going to multiply 5 times 2, which is 10, no? That will be the second term. The third term will be 10 times 2, which is 20, no? And the fourth term will be 20 times 2, which is 40. And then the fifth term will be 40 times 2, which is 80, no? So in factored form, we're going to have 5 times 2, 5 times 2 times 2, 5 times 2 times 2 times 2, and then 5 times 2 times 2 times 2 times 2, no? So in exponential form, the first term will be 5 times 2 raised to the 2, no? 5 times 2 to the first power, 5 times 2 squared, 5 times 2 cubed, 5 times 2 to the fourth. So what do you think will be the next one? No? So look at the other ways of writing the terms. What does 5 represent? So if your answer 5 will be the first term, you are correct. Okay? For any 2 consecutive terms, what does 2 represent? No? If your answer is the common ratio, then correct as well. Now, what's the relationship between the exponent of 2 and the position of the term? No? If you have noticed, no, the exponent of 2 in the first term is 0. The second term, the exponent is 1. The third term, the exponent is 2. No? So for the fourth term of the exponent of 2 is 3. And the fifth term of the exponent of 2 is 4. So which implies that the common ratio is 1 less than the order of any given term. So with that, the exponent of 2 is n minus 2. The first term is 5, no? Using the idea on number 3, we can say that the exponent of the common ratio is 1 less than the order of the term. So we can state that a sub n is equal to 5 times 2 raised to n minus 1. So for us to have the general term for the geometric sequence, we can say that sequence will be written as the n term, no? N term is equal to the first term times common ratio raised to n, or the number of terms, minus 1. Now let's have the, if we're going to have it as geometric sequence, no? Okay. Let's have number 1. We have 3, 6, 12, 24. So 6 divided by 3 is equal to 2. So the common ratio that we have is 2, no? So what will be the next two terms? So 2 times 24 is 48. And 48 times 2 is 96. So those are the next two terms. Next, we have 3, 1, 1/3, and 1 over 9, and so on. So 1 divided by 3 is 1/3. Therefore, the common ratio is 1/3, no? So 1 over 9 times 1/3 is equal to 1 over 27. 1 over 27 times 1/3 is equal to 1 over 81. So those are the next two terms, no? Now let's have number 3. We have -5, 10, -20, and so on. So how are we going to get the common ratio? So for us to get the common ratio, we're just going to have 10 divided by -5, no? So 10 divided by -5, that is a -2. So the common ratio that we have for number 3 is -2. Therefore, for us to get the next term, -2 times -20 will be negative times negative, positive 20 times 2 is 40. So we're going to have a positive 40. And then positive 40 times -2, so we have negative 80. If ever you have seen for number 3, we have an alternate signs. It indicates that the common ratio of this will be a negative. Okay? Okay, let's have number 4. We have -1, -4, -16. The common ratio will be -4 divided by -1. Negative divided by negative is positive, and 4 divided by 1 is 4. Therefore, we have the common ratio as positive 4. And for us to get the next term, -16 times 4 is -64. -64 times -64 times 4 is -256. So those are the next two terms. Okay, so let's have a real life situation. XYRHZ, no, wrote a letter about the issues concerning the COVID-19 through her email and sent it to 3 friends. No? Each of the 3 friends writes the same letter and send it to the 3 other friends. And the sequence is repeated. So assuming that no one breaks the chain, how many letters will have been sent in the 6 mailings? So first we have 3, second we have 9, then the third one will be 27, and then the fourth one will be 81. So 81 times 3, we're going to have 243. No? So on the 6th mailing, we're going to have 243 mails. Okay, so let's have activity number 3. So I'll tell you what you are. You just need to state if the sequences is geometric or not. So the first one, we have 520, 80, 320. So let's try, no? Let's get common ratio. So 20 divided by 5 is equal to 4, no? 80 divided by 20 is equal to 4. Therefore, it's a common ratio. The common ratio is 4. Now, let's have number 2. We have 7 square root of 2, 5 square root of 2, 3 square root of 2, and then square root of 2. Now, if ever we have seen in here, we're just deducting 2, no? It's a -2, no? And that is the last time that we had, no? It's the common difference, and this is not a geometric sequence. Now, let's have number 3. We have 5, -10, 20, and -40. Oh, there's an alternate signs, no? So therefore, it can be a geometric sequence. So let's try if we have a common ratio. So negative 10 divided by 5, we have a negative 2. 20 divided by negative 10 is a negative 2. Therefore, our common ratio is a negative 2. And number 3 is a geometric sequence. Now, let's have number 4. We have 1, 0 0.6, 0 0.36, 0 0.216. So, let's try if we have a common ratio with this. 0 0.6 divided by 1 is 0 0.6. 0 0.36 divided by 0 0.6 is equal to 0 0.6. No? So, the common ratio for this is 0 0.6. And this sequence is a geometric sequence. Now, let's have number 5. We have 10 over 3, 10 over 6, 10 over 9, 10 over 15. Absolutely, this is not a geometric sequence. No? Let's have number 6. We have 4, 0, 0, 0, 0. Let's try. We have a common ratio. 0 divided by 4, 0. 0 divided by 0, 0. Therefore, the common ratio that we have is 0. And this sequence is a geometric sequence. Okay, so let's have lesson 5 for this week 3. See, at the end of the lesson, the learner is expected to compare and contrast the similarities and differences between arithmetic and geometric sequence, and identify and analyze number patterns of arithmetic and geometric sequence. And obviously, the learner must tell whether the given sequence is a geometric or arithmetic, and we need to value the critical thinking skills for this moment. Okay, let's have illustrative examples 2. Okay, in the sequence 3, 8, 13, 18, 23, there's no common ratio at all, no, among the terms. However, there is a common difference, which is 5, no. So 23 minus 18, we have 5. 18 minus 13, we have 5. 13 minus 8, we have 5. 8 minus 3, we have 5. Therefore, this is not a geometric sequence. But then, this is an arithmetic sequence since we have a common difference. Okay, let's have illustrative number 3. So, if the sequence is negative 10, 8, 10, negative 5, and so on. So, can we have the common ratio? Is this what do you call it? Geometric sequence? First, we have an alternate sign. So, maybe, no, this is an geometric sequence. So, let's try to get the common ratio. 10 divided by negative 20. So, we have negative 1/2. Negative 5 divided by 10, we have negative 1/2. Therefore, the common ratio that we have is negative 1/2. Okay? And this one is a geometric sequence. Okay, let's have illustrative example number 4. So, we need to determine the common ratio, no? Determine if there is a common ratio or common difference for 6, 12, 14, and 28. Na? So, let's try. 28 minus 14. Na? So, we have 14. Na? Now, let's have the common difference. 14 minus 12, 2. 12 minus 6, 6. Okay. 80, let's have the common geometric, common difference, common ratio rather. 28 divided by 14, we have 2. 14 divided by 12, we have 7 over 6. 12 divided by 6, we have 2. They have common ratio. Okay. Are these sequence arithmetic or not? What do you think? Okay. Okay, so let's have an arithmetic sequence. Arithmetic sequence is a sequence where every term after the first term is obtained by adding the constant term, which is what you call the common difference. So, n term is equal to the first term plus the number of terms minus 1 times the common difference. While in geometric sequence, we have a sequence where each term after the first term is obtained by multiplying the preceding term by a non-zero constant, which is the common ratio. And the formula that we're going to use is the n term is equal to the first term times the common ratio raised to the number of terms minus 1. Okay, so let's determine the pattern illustrates. Now, if this geometric sequence or not. So let's have 5, 10, 20, 40, 80, and so on. So let's try to get common ratio. So this will be 10, Na po? So, we have 10 divided by 5. No? 10 divided by 5. So, what do we get there? So, we have it as 2. How about 20 divided by 10? Do we get 2 as well? No? So, we have 2 as well. Therefore, we have a common ratio, which is 2. No? So, with this, number 1 is a geometric sequence. How about number 3? Number 2, rather. So, we have 3, 6, 9, 12, 15, and so on. So, we have 6 divided by 3, which is 2. 9 divided by 6, which is 3 halves. So, we don't have the same. No? So, therefore, number 2 is not a geometric sequence. How about the other one? We have 1/8, 1/4, 1/2, 1, and 2. So, that will be 1/4, no? Times the reverse of 1/8, no? So, we're going to have it as 8. 8 divided by 4. So, we have 2. How about the other one? We have 1/2 times 4 over 1, which is 4. 4 divided by 2, we're going to have 2 as well. So, we have the same, no? Common ratio. So, we have the common ratio. If that's so, this is a geometric sequence. Now, let's have number 4. We have 1, 3, 9, 27, 81. So, 3. So, we're going to have 3 divided by 1, 3. 9 divided by 3, 3. So, we have the same. Therefore, we have a common ratio. So, number 4 is a geometric sequence as well. No? How about number 5? Okay, so let's have number 5. We have 10, 9, 8, 7, and 6. And so on. So definitely, this is not a geometric sequence. No? So, we just deduct, no? 10 minus 1, 9, 9 minus 1, 8, 8 minus 1. So, therefore, this is not a geometric sequence. Okay, so what is the fifth term of the geometric sequence 3 over 2, 3 over 20, 3 over 2, and 15, and so on. So, let's take a look. Okay, so your first term, okay, first term is equal to, what's your first term? 3 over 20. Then, your ratio is equal to 3 over 2 times, no? The reciprocal, no? 20 over 3, no? So, 20 divided by 2 is equal to 10. So, that's your common ratio, 10. And then, the number of terms that we are looking for, we have the fifth term. Okay? And then, let's have the nth term. First term times the ratio raised to the n minus 1. Number of terms minus 1. So, a sub 5 is equal to, first term, 3 over 20. Common ratio, no? Let's have 10. And then, no? N minus 1. So, 5 minus 1. So, what will you get? So, we're getting 3 over 20 times 10 to the 4th power. So, what it will be? So, it will be 3 over 20 times 10,000. No? And then, a sub 5 will be 1,500. Okay? So, that will be your fifth. No? 8,500 will be your fifth term. Okay, so we're going to have find the sixth term of geometric sequence where the second term is 6. Now, the common ratio is 2. Now, so we have 6. We don't know the first term. Then our common ratio is 2. So, 6 divided by 2 is 3. 3 times 2, 6. So, your first term is 3. The number of terms, we're looking for the 6th term. So, a sub n equals a sub 1 times the common ratio raised to number of terms minus 1. So, a sub 6 equals the first term, which is 3, times the common ratio, that is 2, raised to 6 minus 1. Therefore, the 6th term is equal to 3 times 2 to the 5th power. 2 to the 5th power, so if we're looking for 2 to the 5th power, that will be 32. 32 times 3, no, is 96. Let's try if we have the correct answer na. So we have 3, 6 times 2, 12 times 2, 24 times 12, 48 times 2, 96. So let's say 1, 2, 3, 4, 5, 6. Okay, so that's correct. So a geometric sequence, which is said to be is a set of terms in which each term after the first term is obtained by multiplying the preceding term by the same fixed number called the common ratio, which is commonly represented as R.